My name is Martin van Ittersum. I'm professor at Wageningen University in Plant Production Systems, and I'm coordinator of the MiBicycle project. The MiBicycle project is a European research project aiming at enhanced biomass circularity of utilization of biomass between our crop and our livestock farms. We focus especially on so-called co-products, and these can be crop residues, manure, cover crops, green waste, and these are actually large volumes in a region, thousands of tons it could be in a region. And they can be plant-based, they can be livestock-based, depending on the types of agriculture that you find in a particular region. I could further explain our project using our logo, which is a bicycle. And the first wheel of the bicycle symbolizes the crop farm, and the second wheel symbolizes the livestock farm. And the project is about cycling of nutrients and carbon within the crop farm and within the livestock farm, but also across the crop and the livestock farm in a coordinated fashion. Agriculture in Europe, but actually also elsewhere, has become very specialized. Farms often focus on crops, or they focus on livestock, and even entire regions tend to be specialized. And that brings advantages in terms of economies of scale and the specialization, but it hinders sometimes the optimal use of exchange of biomass between these two types of farming, because they are not really close to each other. And that is important because we hypothesize that a better co-product utilization across the crop and the livestock farms will be beneficial for a number of aspects. It could have advantages, for instance, for nutrient cycling, first of all, for lowering the greenhouse gas emissions, for a better soil carbon sequestration in our soils, and finally, and of course important for the farmers, productivity. So in short, we hypothesize, we test the hypothesis that enhanced co-product utilization leads to climate change mitigation and to more sustainable systems. We use a couple of research approaches and investigate our objectives at the level of individual farms, but also for the entire landscape. So as you could say, a summation of all the farms in a region. And we try to serve different stakeholders, researchers, our colleagues, but also people from the agricultural industry, policymakers, and even students. And we make maximum use of four very contrasting case studies that we have in our project through our 5 partners. Drenthe, which is a province in the north of the Netherlands, the central Danish region in Denmark, of course, and then eastern Scotland, and finally the Ariège region in southern France. And to achieve all this, a core aspect of our project, of our methodology, is a summary computer model to assess the 4 indicators for nutrient cycling, greenhouse gas emissions, carbon sequestration, and the 4th, productivity, both at farm and at regional level. And typical for that model is that it's as the word says, it's a summary model, so we have tried to keep it as simple as possible. And it uses publicly available data, so we don't need to spend a lot of time on bringing all these data together if we want to apply it to a new region. The model generates then results which can be of interest not only to researchers, but also to regional policy and decision makers. Yeah, an example of the results of using that model is what we did for the province of Drenthe in the north of the Netherlands, where we looked at 2 ways of utilizing the manure. There's quite a lot of livestock in that province. So we compared the direct use of the manure as a fertilizer for the crops against first anaerobically digesting the manure and to produce biomass and digestate, and then use the digestate as a fertilizer for the crops. So direct use of the manure versus anaerobic digestion, and then using the digestate as a fertilizer. And to put these 2 alternatives in the perspective, and whether the advantages or disadvantages of one method above the other, to put that in a perspective, we compared it against lowering the use of artificial fertilizers and using less important feed for the livestock farms. And in the video about the model, there's a more detailed video about that, we explain much more about what you can learn from the graph that you see on the screen. Next to that summary model, we also developed what we call a serious game. This is, as the word says, it's a game, but played that can be played by students or potentially also other stakeholders, as if they are the farmers and the decision makers in a region that have to decide upon how they use the co-products, such as manure or crop residues, to get the best environmental and economic results. It's a game, but a serious game. And again, in the video about that serious game, you will hear much more details about it. Well, next to the model and applications and next to the serious game, we also show some examples of best practices, you could say, of the use of biomass in the different regions. We show biogas plants in Denmark and how that functions, and how crop and livestock farmers can collaborate by implementing cover crop grazing in France and in Scotland. So I'm hoping that I've given you a first introduction about the MiBicycle research project and its different components. In other videos you will learn more about what we've developed and how we've applied it in our research to the 4 case study regions of the project. And I really hope you will enjoy it, watching it, and that you can use the knowledge that we generated in your own work.